Today, we are diving deep into a really fascinating paper that tackles one of the biggest hurdles in AI right now. How do you teach a model to actually use tools? This is, and I'm not exaggerating, a massive step toward creating the kind of autonomous AI agents that can really act in the digital world. Let's get into it. All right, so here's our game plan. First, we're going to unpack the huge problem AI has with using tools. Then, we'll introduce Gorilla, the specialized model built to fix it. We'll look at the clever way it was trained, see how it performs against the big names, and then we'll talk about what this all means for the future of AI agents. So, what's the core issue here? Well, large language models, or LLMs, are brilliant. I mean, they've processed a huge chunk of the internet. But here's the catch. All that knowledge is basically trapped. They can talk a great game about what to do, but they can't actually do it on their own. And that leads us to the million-dollar question, right? How does an AI go from just spitting out text to actually taking action, booking a flight, crunching some numbers, or maybe even controlling another piece of software? The answer is something called an API. Now, you can just think of an API as the universal language that lets different software programs talk to each other. For an AI, learning to use APIs is like a super smart brain suddenly getting a set of hands. It's the critical bridge between knowing something and actually doing something. But you guessed it, there's a big problem. And this slide just lays that problem out so perfectly. You give a simple request to find a tool, and look what happens. GPT-4 literally just invents one that doesn't exist. That's a hallucination. Then you have Claude, which tries, but it pulls a tool from the completely wrong library. And then there's Gorilla. Nailed it. Perfect. This unreliability is the single biggest barrier to building agents we can trust. So let's be really clear here. There are two major ways these powerful models fail. You've got hallucination, where they confidently make stuff up, and then you have simple errors, where they grab a real tool but just don't know how to use it correctly. Either way, the result is useless. Okay, so how do we fix this mess? Well, this is where researchers from UC Berkeley and Microsoft Research step in with Gorilla, a model designed from the ground up to be an absolute expert at one thing: using APIs. Now, what's so cool about this is that Gorilla isn't some behemoth model like GPT-4. Nope, it's built on the much smaller Lama 7 billion parameter model. It was fine-tuned, which is just a way of saying it was intensely trained to do one job and do it better than anyone else. And that job is writing perfect API calls. So, how'd they pull it off? Well, the secret sauce, as they say, is all in the training. It involved creating a brand new, highly specialized dataset built just for this purpose. This was the puzzle the researchers had to solve. I mean, think about it. If you want an AI to navigate the thousands, maybe millions of digital tools out there that are constantly changing, you need a smart way to teach it. You can't just feed it a few examples and hope for the best. So, step one, they went on a shopping spree for tools. They scraped all the documentation for machine learning APIs from huge hubs like Hugging Face and PyTorch Hub. These are the places where the pros share their code. And they didn't mess around. The scale of this was pretty huge. They collected a whopping 1,645 unique APIs to create their own custom dataset, which they called API Bench. This became the bedrock of Gorilla's entire education. Okay, so here's the four-step recipe. After they collected all those APIs, they used GPT-4 to generate tons of different user requests for each one. Then they trained the base Llama model on all these question and answer pairs. But step four is the stroke of genius. They added a retriever, which basically taught the model how to look up the latest instructions while it was learning. It's like teaching it to study with an open book. So the training method sounds really smart on paper, but did it actually work? It's time to look at the numbers and see how Gorilla stacked up against the competition. And the results? Well, they speak for themselves. In a head-to-head test with no hints or extra help, Gorilla hit nearly 60% accuracy. Compare that to GPT-4, which didn't even break 40%. But the jaw-dropper is the hallucination rate. GPT-4 was just making things up over a third of the time. Gorilla? Less than 7%. That is a night and day difference in reliability. And hey, don't just take my word for it. The researchers say it loud and clear, right in the abstract of the paper. Gorilla surpasses GPT-4, and it substantially mitigates hallucination. That's the headline right there.
Now, you might be thinking, well, what if you give GPT-4 that same open book advantage with a retriever? Great question. They tested that too. And as this chart shows, even when you level the playing field and give everyone a retriever, the specially trained gorilla still comes out on top. It just proves that the specialized training really was the magic ingredient.
Okay, so let's zoom out and talk about the big picture, because this isn't just a cool academic result. This has some really serious implications for where useful AI is heading. The biggest innovation to remember is this idea of retriever-aware training. Think about it. Because Gorilla learned how to learn from new documentation, it can adapt on the fly when tools get updated or new ones come out. This means you don't have to retrain the whole model from scratch. That makes it so much more practical for the real, messy, ever-changing world. And this unlocks the future the researchers are dreaming about. Imagine complex jobs like planning and booking an entire vacation from start to finish, or organizing a whole conference, becoming as simple as just talking to an AI agent that you know can reliably find and use every single tool it needs. So, for all you developers and builders out there, the takeaways are pretty clear. First, bigger isn't always better. A small, focused model can crush a huge one on a specific task. Second, the quality of your training data is absolutely everything. And third, if you want your agents to be useful for more than a week, you need a retrieval system. And finally, you have to solve hallucination. It's the key to building agents people can actually rely on. Which kind of leaves us with one final question to ponder. If you had an AI that could finally, reliably use any tool you pointed it at, what's the first complicated, annoying, time-sucking task you'd hand over to it? The possibilities are really starting to feel endless. This is for entertainment purposes only.